This is section 3.1, complex numbers. Complex numbers are, they represent, that's how we write all of our imaginary numbers. They're in the form of a plus bi, where a is the real part and bi is the imaginary part. Remember that I is equal to the square root of -1. So we've talked about imaginary numbers before. So if we had the square root of -36, remember that was plus or minus 6i, because that's like the square root of 36 times the square root of -1. Square root of 36 is plus or minus 6. Square root of -1 is I. When we plot complex numbers in the complex plane, instead of an x and a y, we're going to have a real and imaginary. So our x-axis is the a number, or the real part, and the y-axis is our b number, or the imaginary part. So if we are trying to plot these complex numbers in the complex plane, so the first one, 3 minus 4i, I'm going to do in orange. So the real part is 3, and the imaginary part is -4. So 3, 1, 2, 3, 4. So there is the number 3 minus 4i. All right, I'll do this one in purple. So -4 minus I. Our real part is -4, and our imaginary part is -1. So we graph it there. This one I'm going to do in blue. So remember, this is like 6 plus 0i. So we go 6 on the real axis, 1, 2, 3, 4, 5, 6, and then it stays on the axis because it's a real number. And last one I will do in green. Remember, this one's like 0 plus 5i. So we just go up 5. Adding and subtracting complex numbers, what you're going to do is you're just going to put the real parts together, and you're going to put the imaginary parts together. So in this case, the real parts are 3 and 2, so 3 plus 2 is 5. And the imaginary part is -4i plus 5i, which is just plus 1i. For this subtraction one, remember, this is like 2 plus 5i minus 3 plus 4i. We distributed that negative. So if we look at the real parts, 2 and minus 3 gives us -1. And plus 5i plus 4i is going to be plus 9i. Pretty simple. Multiplying complex numbers, treat it like you would treat a polynomial. Okay, so a lot of it's going to be the FOIL method, or the distributive property. Just for reference, I is the square root of -1. I squared is -1. I cubed is the same thing as -i, which is negative square root of -1. And out of the fourth is 1. So to do this example, the first one we would distribute. So -4 times 2 is -8. -4 times 6i is -24i. For this one, we are going to do the FOIL method. So 4 times 2 is 8. 4 times -5i is -20i. 3i times 2 is plus 6i. 3i times -5i is -15i squared. So we have 8, and then -20i plus 6i is -14i. And I squared is -1, we know, which makes this 8 minus 14i plus 15, which we can simplify to be 23 minus 14i. So when you have a FOIL one like this, make sure that this I squared term gets simplified by using I is equal to -1. So dividing polynomials, write the division problem as a fraction if it isn't already. And we don't like to have complex numbers we don't like to have imaginary numbers in the denominator. So we're going to multiply the denominator and the numerator by the conjugate of the denominator and then simplify. If you don't remember what a conjugate is, okay, so if we have 3 plus 4i, the conjugate is going to be 3 minus 4i. If we have 6 minus 8i, our conjugate is going to be 6 plus 8i. So to find the conjugate, you just switch the symbol in between the real and the imaginary part. So this first one, 2 plus 5i divided by 4 minus I. So let's write that as a fraction. So 2 plus 5i over 4 minus I. We don't like imaginary numbers in the denominator, so we're going to multiply by the conjugate, which is 4 plus I. So let's do a little bit of this over on the side. So 2 plus 5i times 4 plus I. We get 8 plus 2i plus 20i plus 5i squared. Okay, I know this 5i squared is the same thing as -5. So 8 minus 5 is 3, and then 2i plus 20i is 22i. So we know on the top we're going to have 3 plus 22i. And then 4 minus I times 4 plus I. We get 16 plus 4i minus 4i minus I squared. Notice that when we multiply by the conjugate, these middle terms cancel out. And a minus I squared is a plus 1, because minus -1 is plus 1. So we just get 17. So our answer is 3 plus 22i over 17, because it can't be simplified. All right, let's do one more example. So we're given that f of x is equal to 2 plus x over x plus 3, and we want to find f of 10i. So let's plug in 10i for x. So we have 2 plus 10i over 10i plus 3. I'm going to rewrite the denominator to be in our normal form for complex numbers. So it's going to be 3 plus 10i. We have an imaginary in the bottom, so we're going to multiply by the conjugate. So 3 minus 10i over 3 minus 10i. And then let's do some multiplying. So 2 plus 10i times 3 minus 10i. We get 6 minus 20i plus 30i minus 100i squared. So that becomes 106 plus 10i. And on the bottom, 3 plus 10i times 3 minus 10i. We get 9. I know those middle terms are going to cancel out. And then we have minus 100i squared. So that becomes 109. So we end up with, oops, reading the wrong thing. We end up with 106 plus 10i all over 109.